Many northern countries are now looking towards the Arctic in order to further their economic and mineral reserves. This is because of the large quantity of resources present in the northern end of our planet, such as oil and precious metals. As a result of the high demand, many mechanical engineers have had to design machines and tools capable of assisting in Arctic exploration and development. One such machine is an icebreaker ship. These are ships specifically designed to crack through large chunks of ice in order to make transportation through the Arctic possible. There are three design aspects that separate icebreakers from other ships. These are the shape of the hull, structural design, and propulsion systems. As icebreakers are still ships, their hydrodynamics and efficiency in the water are still a key factor in their design. However, unlike most ships, icebreakers must be able to not only withstand the force of the ice, but be able to break it up and clear it away as fast as possible. The problem lies in finding the balance point between efficiency and icebreaking. Flare is a key component of the design process and refers to the angle formed between the bottom and deck of the ship relative to the surface of the water. A ship with an angle close to 90 degrees has a small flare. Ships with smaller flare are more resistant to ice-breaking forces. However, they sacrifice in efficiency and stability of the ship. As a result, a compromise is made with icebreakers in order to maximize efficiency and stability and to minimize ice-breaking forces. Because of the extreme conditions on which icebreakers operate, the overall structure of the ship must be adapted in order to be able to withstand the ice-breaking forces as well as the Arctic temperatures of the water. Icebreakers must be reinforced along both above and below the waterline in order to withstand the load applied by the ice as it is broken up and swept aside. The front of an icebreaker can also be used to crush thick patches of ice with its weight if the icebreaker is driven on top of the ice, and as a result, it must be heavily reinforced in order to withstand the resulting forces. Modern icebreakers make use of a high-strength steel with a yield strength of 500 megapascals in order to lessen the amount of material needed to reach the same structural strength. However, the most important factor in the structural design of an icebreaker is the capability of the steel being used to resist stresses induced by the frigid temperatures. By factoring in both temperature and the loads that must be endured, the correct grade and thickness of steel can be selected for each part of the icebreaker. Modern icebreakers have three main types of engines. The most common are diesel-electric generators. These have a diesel engine coupled to a generator to produce electricity. Typically, these use alternating current generators as they are more powerful than their direct current counterparts. Another type of engine used is a mechanical powertrain, where diesel engines are coupled to reduction gearboxes and propellers. Mechanical powertrains are more efficient and take up less space than a diesel-electric generator. However, they are more sensitive to variations in torque that can be caused from ice coming into contact with the propellers. The third main kind of engine is nuclear-powered. These engines are the most powerful of the three and are used solely by Russia. In these, a nuclear reactor is used to produce steam for turbogenerators, which uses a turbine to generate electricity. These turbogenerators in turn produce electricity for propulsion motors. Outside of these three main types, there are several experimental and specialty designs to suit any kind of need for icebreakers. Each engine has its own benefits and drawbacks, and as such, icebreakers can be designed for a wide variety of conditions. So in summary, I have talked about three key aspects of the design of icebreakers. The shape must be designed in such a way that it minimizes ice-breaking forces without sacrificing too much of its efficiency or stability. The ship must be built out of a high-strength steel that is resistant to stresses from cold temperatures and must be reinforced along the front of the ship as well as along the waterline. The ship also requires a powerful engine, which can be diesel-electric, mechanical, nuclear, or a special kind of engine in order to suit the specific needs of the particular icebreaker. Each aspect that makes an icebreaker unique from other ships is a feat of mechanical engineering, and is a prime example of how mechanical engineers are contributing to exploration and development in the Arctic. Thanks so much for watching. I really hope you enjoyed it.